Good morning, guys. Welcome to today's lesson, April 17th, secants and tangents, and we're finding the length more specifically with those segments. Our do now. A 20-foot support post leans against a wall, making a 70-degree angle with the ground. To the nearest tenth of a foot, how far up the wall will the support post reach? So we have our wall, we have the ground, and we have the support post, which leans against the house or the wall. And that acts as the hypotenuse of the right triangle that's formed. So remember with these questions, right, the wall is perpendicular to the ground, and the post is leaning against that wall. Alright, so let's label based on what they told us. So the 20-foot support post. So this post is 20 feet. Leans against the wall, making a 70-degree angle with the ground. So your 70-degree angle is the post and the ground. How far up the wall will the support post reach? So we need to find out essentially the length of the wall here. So we have a classic trig ratio question, nice SOHCAHTOA. So in talking about Algebra 2, this is something you will absolutely need for Algebra 2. So do not forget about your trig ratio, sine, cosine, and tangent. Remember, we lock in on our angle, and we label accordingly. So in relation to that angle, the ground would be adjacent, the wall would be opposite, and the hypotenuse is 20 there. So now remember, we have to pick, is it sine, cosine, or tangent? Based on this angle, we have to say, all right, what are we given and what are we looking for? All right, we're given the hypotenuse and we're looking for the opposite, so that tells us we're working with sine. Just remember that what that ratio is, sine of some angle, theta, is equal to the opposite side over the hypotenuse. All right, substitute what we have. Sine of the 70-degree angle is equal to the opposite side, which is our unknown, over 20, the hypotenuse. Now you're just cross multiplying from here. Remember, this is over 1, or you could type in the equation exactly as you see it into GeoGebra and then use the graph, find the x-intercept where the line crosses the x-axis, and you'll see your solution or your root. All right, but at the end of the day, it's 20 times sine of 70, or sine of 70 times 20, and that comes to choice 4. Got to be careful with rounding in this problem. Don't pick 18.7. It was 18.7, something bigger than 5, so it rounds up to 18.8. All right, so how do we solve for missing segments in a circle? So this is all about finding segments. We've been dealing a lot with angles. The only day we worked with segments is one of the intersecting chords day, but this is more focused on, all right, there's a secant, there's a tangent, there's two secants, whatever it might be, but there's a couple different rules for finding out, all right, how long is that secant? How long is that tangent? All right, so we'll get a diagram that looks something like this. This would be a secant, because if you look at segment AC, from A through to C, that's a secant, it hits the circle twice. Now from A to E, that's a secant, hits the circle twice. So they might say in this problem, whatever, find the length of BC. Find the length of AD, and there's a general equation that we use for that. So what is the secant rule? It's the tangent of it times the secant is equal to the tangent times the secant. Now, you might be saying, where's tangent coming from? Those are two secants. Well, the tangent is just AB. All right, the secant is the entire piece here, AC. All right, the tangent is just from down here, AD. The secant is A through to E. All right. Now, you're not going to hear me saying tangent, secant, all that. There's two pretty easy equations that we can remember a little more easily. All right, we call it OW. So the outside times the whole is equal to the outside times the whole. The outside is the tangent, and the whole thing is the secant. So OW is equal to OW outside AB in this case. So the outside would be AB times the whole thing, which would be AC, is equal to the outside of the other piece, right, AD, times the whole segment, the whole secant, and that's AE. So that would be your equation, and then one of those are going to be your unknown. So OW equals OW. When do we use it? It's when we have a diagram like this where there's two secants drawn in. Okay, let's try it out. Number one, in the accompanying diagram, segment PAB and segment PCD are secants drawn to circle O. PA is equal to 8. Let's fill that in. PB is equal to 20, so PB. Be careful of how you fill that in. That's the whole piece. And PD, the whole piece again, is equal to 16. What is the length of PC? Alright, so always be careful about labeling. So this is two secants. We know our rule is OW equals OW. And what does it mean? The outside piece times the whole thing is equal to the outside piece times the whole thing. So your outside piece, let's look at the top here for PD. Outside PC is equal to X. The whole thing, the whole piece is 16. And now that's equal to the outside piece again down below, which is PA. The outside is 8, and the whole thing is 20. So the outside piece times the whole piece is equal to the outside piece times the whole piece. Alright, so let's take a look. Simplify now. We have 16x is equal to 8 times 20, which is 160. Divide by 16, and you get x is equal to 10, which would be choice 2. Now they could weirdly ask you in a problem like this, they could ask you for a CD. So you would have had to find the outside piece, right? That outside piece now we found is 10. And then you just would have to say, okay, if that's 10 and the whole thing is 16, I know that this piece is 6 over here. So you never know what they're going to ask you for. Just be careful. But at the end of the day, the equation here allows you to find the outside, which might help you find that inner piece. All right. Another one with a couple of secants. In the diagram below, secants PQR and PST are drawn to a circle from point P. If PR is equal to 24, right here, and PQ is equal to 6, so that's the outside piece, and PS is equal to 8, determine and state the length of PT. The whole piece, your unknown. So, two secants, OW equals OW. So the outside, I'm going to work with the top section. The outside is 6. The whole piece is 24. Now the bottom section, the outside is 8. And the whole section is the unknown of x. So we get 144 is equal to 8x divided by 8. And you get x is equal to 18. Now we're done, but just keep in mind we found that this outside piece is 18. They might not have asked you for that. They might have said, what's TS here? What's that inside piece? You do the exact same thing. What the equation allows you to find is not that inner piece. The equation in this case allows you to find the whole thing, so you could strategically use that 18, subtract 8 now, and just know that this piece is 10. All right, you never know what they're going to ask you for. Be careful. All right, now, a secant tangent. So this line right here, that's a secant. It hits the circle twice. And this line right here is just a tangent. It hits the circle only one time. So what's the rule when we're dealing with a secant tangent? The rule is the tangent squared, so the tangent multiplied by itself is equal to the tangent times the secant. All right. So the tangent here is a, right there, right? So that would be a squared is equal to, now the tangent below is b, and they're just saying that outside section, b. So is equal to b times the secant, which that's actually the whole thing. It's not, the whole thing is represented as c right now. That's talking from here in yellow all the way through the whole piece. So you don't have to get caught up in those letters. I know that's a little bit confusing. At the end of the day, you'll see how it's used. It's really O squared is equal to OW. The outside times itself is equal to the outside times the whole. Now, this is something just to think about. This is really the exact same rule. OW equals OW. Here's why. You might be confused about this section right here. How is it the same thing? Well, O squared, the outside for letter A up top here for the tangent, the outside and the whole are the exact same thing. The outside is the whole thing. Alright, so O squared is just the outside times itself. The outside and the whole are the exact same thing. So we're going to write O squared equals OW, but just thinking about it logically, it's the exact same rule. Alright, O squared is equal to OW. Where's O squared coming from? It's still the outside times the whole, because the outside times the whole, they're the exact same thing. They're the exact same number. They're the exact same segment, the outside and the whole. Alright, so let's see how this looks in a problem. In the accompanying diagram, PA is tangent to circle O. You see how PA only hits the circle one time. PBC is a secant. Alright, PB is equal to 4. They filled that in for you. And BC is equal to 8. What is the length of PA? Now, guys, keep in mind, they're asking you right now to work with a tangent and a secant. Alright, a tangent and a secant. So remember your rule. This is not going to be overly challenging math. It's not going to be overly challenging to solve. It's going to be hard to remember all these different rules we've been working with. Alright, so just recognize when I write something like this, O squared equals OW, that's the rule for today. You have to be thinking, when do I use that? Alright, I use that right now when I'm dealing with a tangent and a secant. Before it was two secants, now it's a secant and a tangent. Alright, so the outside times itself is the unknown, so x squared. The PA times PA, or x times x. So the outside times itself is equal to the outside, which is 4, times the whole, which a lot of students write 8 here. The whole thing is not actually 8. Be careful. We want the whole piece, not the inside piece. None of this has the inside piece involved. It's either the outside or the whole thing. The whole thing right here is 8 plus 4, which is 12. So this would be 4 times 12, outside times the whole. So you get x squared is equal to 48. Square root both sides. Now at this point you could write x is equal to radical 48 and find out that decimal value in your calculator and then see which answer choice matches that. So it would end up coming to, when you do that, it comes to choice 3. But also in the spirit of Algebra 2, where you will need this skill, let's talk about how to solve it. We need the biggest perfect square that divides evenly into 48, so that means you need to know your perfect squares. 1, 4, 9, 16, 25, 36, and then anything bigger than that can't go into 48. So the biggest perfect square that divides evenly into 48 is 16. So now you write it as two radicals, radical 16, and radical 16 times what gives me 48? That would be 3. Now the perfect square will simplify to 4, and the 3 that's not a perfect square just stays as is. So that's where 4 radical 3 comes from. Alright? So remember this O squared, I just want to focus in here. This O squared here, that's the tangent. Okay, that's the section for the tangent. It's the tangent times itself. Alright? 11. In the diagram of circle O, secant ABC and tangent AD are drawn. If CA, so the whole piece here, is equal to 12.5, and CB is equal to 4.5, so that's the inside piece, determine and state the length of DA. So that's the tangent again. So you write your rule, right? O squared equals OW. Why did we write that? Why didn't we write OW? Because that's when we're working with two secants. Right now we have a secant, hits the circle twice, and a tangent hits the circle once. So then we write O squared equals OW. Alright, O squared is equal to, right, that's your tangent, so this is x squared again. It could have been a number. If they give you the tangent, that'll be a number. That's equal to the outside piece, which is 12.5, times the, not the outside piece. Let's back up a step. What's the outside here? The outside here, if you're not careful, it'll catch you. BA is the outside piece. So how would I find that outside piece right now? You'd have to take that whole thing, right, 12.5, and subtract the 4.5. So you would get here for your outside piece, that would be 8. So the outside is 8. And the whole piece is what? 12.5. So you see how we're not using that inner piece, the 4.5? We're using it to get the 8. But in your equation, you should not be using the inside piece of that 4.5. So it's always the outside, which is 8, and the whole, which is 12.5. So 8 times 12.5 is equal to 100. Square root both sides. And you get x is equal to, it's actually 100, it's perfect square. X is equal to 10, right? 10 times 10 is 100. And you're good to go. So what I want you to do is try these two problems. Think about what equation would you be writing? O squared equals OW, or just OW equals OW? You have to decide that. All right, here you're working with a secant and two secants, and here you're working with a secant and a tangent. So just be careful about which rule you're using. So those two problems. Message me and remind if you have any questions. Check back later in the day for your answer key. Make sure you correct your work. Your Delta Math was due last night at 8 o'clock. However, it's still open for a lot of the credit. So if you didn't get a chance to take a look at the Delta Math, please do that today. The window will stay open till about 8 o'clock tonight. All right, have a wonderful weekend, and I'll see you on Monday.